Hello everyone, in this video tutorial we will see how we can do face detection with gender classification and face counting with tracking using YOLOv8 and VGG16. So let's get started and see the complete workflow first. So here you can see the complete workflow on your screen now. So this is the complete workflow. I will explain you the complete workflow first and then we will go towards the code part. So in the workflow, first you can see over here, we have the dataset preparation step. So in the dataset preparation step, we will gather a dataset of men and women images. So we can train the VG16 model for the gender detection. So after collecting the dataset for the men and women faces, then we will train the VG16 model for the gender classification or the gender detection. We will train the VG16 model so that it can detect whether this is a man face or the woman face. Then in the next step, we will train the YOLOv8 model for the face detection. So we will use YOLOv8 model for the face detection. So after detecting the face using YOLOv8, we will do the gender classification whether this is a man face or woman face. Okay. So for example, we have a video like we have seen previously. In this video, using YOLOv8, first of all, we will detect the face. Where is the face in the video? So after detecting the person face, we will apply the trained VG16 model to do the detection whether this is a man face or the woman face. Then we will integrate the DeepSORT object tracking. So using DeepSORT object tracking, we will assign each a person or the detected face a unique ID like 156. And in the last step, I will run the predict.py file and test my script on multiple videos and show you how the results look like. So let's go towards the coding part and explore what we can do here and discuss in detail the code as well. So let's get started. So now we will fine tune, or you can say train the VGG16 model on the gender classification dataset. Basically, we are applying transfer learning. We are taking a pre-trained VG16 model and we are retraining or fine tuning the VG16 model on the gender classification dataset. Okay, so this whole notebook is divided into in these 9 steps, which you can see over here. So in the first step, we will import the required libraries. In the second step, we will mount the Google Drive with this Google Colab notebook. Why we are mounting the Google Drive with this Google Colab notebook? Because I have uploaded the dataset zip file in the Google Drive. So we will mount the Google Drive to access the dataset from the Google Drive into our Google Colab notebook. So we can train the VG16 model for the gender classification. So after we mount the Google Drive with the Google Colab notebook and we have the access to the dataset, in the drive, then we will load the dataset into our Google Colab notebook, and then we will convert the images, all the dataset images into an array. And plus we will also convert the labels of men and women, which is assigned to each of the image into an array as well. Then we will do the train test plate. We will consider around 70% data for the training purpose and 30% of the data for the test purpose. In the next step, we will apply data augmentation. So we use data augmentation when we don't have very much large data set. So data augmentation help us to increase the data set. So using a data augmentation, we can generate multiple images from a single image by rotating the image into plus 15 or negative direction, generating a horizontal flip by just changing the brightness. So we can generate a multiple images from a single images using data augmentation. So to do data augmentation, I will be using image data generator. Then I will fine tune or train a VG16 model on the gender classification dataset, and then I will plot the training and the validation loss, and then I will take a sample image of myself and test whether the model is able to detect correctly. Uh, okay, so in the first step, I will import all the required libraries. So here I am using import cv2 library to read the image or to resize the image. Then I am using importing TensorFlow SDF, and then I am importing image data generator to implement data augmentation. And here I've imported IDEM optimizer, and here I've defined model library. Then here I have defined image to array library. So as I explained already, Grass provides the image to array function for converting a loaded image. So when we load a sample image, it's in the form of PIL format. So using image to array library, we convert the loaded image into a NumPy array. So as you can see here, class provides the image to array function for converting a loaded image in PL format into a NumPy array. Okay, for the use with deep learning model. So we convert any of the loaded image into a NumPy array using the image to array library. And to convert the, for example, we have converted the image into an array using image to array library. So what I want is I want the image back. Okay, so using array to image function that can be used for converting the NumPy array of pixel data into PL image. So if we want to convert after converting the image to an array, I want to convert the array back to the image. I will use the array to image function that will be used for converting the NumPy array into back to the image. Okay. Then we have the from TensorFlow.class.utils import two dash categorical. So basically it converts the integer. For example, we have multiple classes 1, 2, 3. So it generates the binary format. It converts the class vector integer like 1, 2, 3 into the binary format, which is in the form of, for example, if we have 3, then it will be in the form of like 001. And if it is 0, then if it is 0, we have it is in the form of 100. And if it is one, if it is if it is 1, then it will be in the form of like uh, 01. Okay, so in this form it will be. So basically convert the integer into class matrix. Okay, so we are importing the two dash categorical library. Or next we have the sequential. So basically what we do is there are two approaches like sequential and functional approach. So as we want to arrange our layers like convolution 2D layer, max pooling 2D layer, flatten layers into a sequential order. Okay, we can use the functional order as well. So using functional approach, we can connect any layer with any other layer. Okay, we can connect the first layer with the last layer as well. But using the sequential method, we basically arrange all the layers step by step. Basically, to arrange the cross layer in a sequential order. Like in the first step, we have defined the model sequential. Then we have the convolution 2D layer. Then we have the max pooling 2D layer. So in sequential order, we cannot connect the first layer with the last layer. While in the functional order, we can connect our first layer with the last layer. While in sequential order, we move step by step. Like first we define the convolution layer, 2D layer, then we define the max pooling, then we have the flatten layer. So we do all this step by step. While in functional, we don't follow the steps. We can connect any layer with any other layer, but in sequential, we cannot connect any layer with any other layer. We need to follow step by step, like sequential. First, we define the sequential, then we have the convolution 2D layer, then we have the max pooling 2D layer. So we go step by step. Then we have the flatten layer. So flatten layer is used to make the multi-dimensional input into one-dimensional. Okay, so when we apply when while implementing convolution neural network, we want to convert the multi-dimensional input received from the convolution layers into one-dimensional. Then we use the flatten layer. Okay, so while implementing convolution neural network, usually we use the flatten layer to convert the multiple dimensional input received from the convolution layers into one dimensional input that we can pass to the dense layer and get the output. So to do this, we use the flatten layer. Okay. Then we have the dense layer. Usually in convolution neural network, we define our output layer size. What is the size of our output layer? So as we are implementing the transfer learning over here, so to implement the transfer learning, we will be using VGG16. Okay, we can also use mobile net model, efficient net model, but here I'm using VGG16. Okay, so next we are importing the train test plate. So as our data set is not in the form of training and testing and validation set, so using train test plate, I will just split my data set into a training test and into the test set. So 70% of the data will be used for the training and the 30% of data will be used for the testing purpose. Then we have the NumPy array. So when we want to convert a list into an array, then we use the NumPy. So matplotlib library is used when we want to plot some output or input image. Then we have the import OS, and then we have the import GLOB. So we use GLOB library when we want to access all the files in a folder. So there we will use GLOB library, and we have the random. So if you want to shuffle our image data set, so we will use the random function to shuffle our random library to shuffle the images in our data set. So just run all these cells which I have explained above over here. So just give me a minute so I can run all these cell, all the steps which I have explained. So next, what I am doing is basically I am just mounting my Google Drive with the Google Colab notebook. Basically, I have placed the dataset into the Google Drive. So I will just share the dataset file with you as well. So you can also place this dataset on your drive as well. So here I am just mounting the Google Drive with my Google Colab notebook by just running this cell. So in this way, I will connect the Google Drive with my Google Colab notebook over here. So this might take few seconds. Okay. So in this way, we will mount the Google Drive into with our Google Colab notebook. So we can access the dataset from the drive and download this dataset into our Google Colab notebook. Okay, so this might take few minutes. So we have mounted the drive with our Google Colab notebook over here. So if I go over here, drive and here, then we can see if we see over here, you can see that here I have uploaded a dataset in the zip format. So I will just click on copy path over here. Okay, so I've just uploaded a dataset into a zip format. You can also upload the dataset in zip format in your drive. So just click on copy path and just paste this path over here and unzip this dataset from the drive into the Google Colab notebook. So now I'm unzipping the dataset from the drive into my Google Colab notebook. So this might take few more seconds. Okay, so let's wait and see what results do we get. So now we have unzipped the dataset over here. Now you can see that the dataset is completely unzipped. And if I click over here, now we have the dataset folder over here, gender dataset face, and the dataset folder contains men and women images. So if I go over here and click this, let me just show you one sample image over here. So these are the men and women face images, which you can see over here. So this is a man face image. In this way, we have multiple images in this folder. And if I go over here in this woman folder, we can also see the woman images, face images over here. So these are the woman face images. So here we have the data set over here. So now we have downloaded the data set from the Google Drive into our Google Colab notebook. So now using the GLOB library, I will access all the files in this dataset folder, which we have gender data dataset face in the men's and women folder. So in this basically cell, we want to access all the image files which we have in the men and women folder, both in both those folder. Okay, so then we will convert all these images into an array format. Okay, so now we have all the files which we have in this variable. Like you can in the image files variable, we have stored all the file paths of the images which we have in the men and women folder. So all the images which we have in the men and women folder, we have saved those file paths in the image.files variable. Okay, next if we go ahead, now we are just shuffling our images. Okay, and we have defined the image size as 100 cross 100. 3 means RGB, and this is the width and height, and 3 is the RGB because we have RGB channel over here. So we have written 3. So we have created two empty list over here. Data, one by the name of data and other by the name labels. So in labels list, we will store the labels where label values like it is a man or a woman, 1 or 0 values. If it is a man, the value will be 0, and if it is a woman, the value will be 1. Okay, the label value will be 1. And in the data list, we will store the array, like we will convert the image into an array, and we will store the array values or of array of all the images into the data list. Okay, basically in data list, we will store all the images into an array format. We will append all the images into an array format in the data list. Okay, so here I'm just checking a sample image. So you can skip this step and just come over here. So now in the I have to tell you that image dash files variable contains all the images file paths of the men in the men and woman folder. So whatever images we have in the men and woman folder, image dash files variable contains all those file paths. Okay, so we will read all the images one by one which we have in the image dash files variable. So we will read men and all the images which we have in the men and women folder using cv2.imread. I will read all the images which we have in the men and women folder and resize them and convert all those images into an array. Okay. And after converting those images into an array, I will store the arrays values into the uh, data list over here. And plus I will, if the label is woman, then I will store the label value into this list as well. So labels list as well. So if the label is woman, then we will assign a value 1. If the label is man, then we'll assign the value as 0. Okay. So we are just appending the label values into the labels list. So if we have woman, then the label value is 1. If we have men, the label value is 0. So now we are just converting the list like which we have in the data list. I will just store the image. We have converted the image to array and we have stored the arrays values of each of the image in the data list. So I'm just converting that list into an array over here. So now we will convert the basically what I have explained you now. Basically, we will convert this data in which we have the in the data list we have converted the images into an array, and then we will store each of the image array into the data list. While in the labels list, what we do is basically in the labels list we can have stored each of the image label like it is man or woman. So each of the image label is stored in the labels list. So we are just converting those lists into an array over here. So let me just run these cells in the meanwhile, and then we can proceed further by running the cell in the meanwhile as well. Okay, so just run this cell as well. So after converting the labels into an array and after converting the images into an array and storing those array values into the list, and after this we convert the list into an array using np.array. So after doing this we do the train test plate. So we will use 80% of the data for the training purpose and 20% of the data for the test purpose. So here we are just doing the train test plate over here. So here we have done the train test plate. Now what we do is basically we use the to dash categorical to convert the integer values into the binary class values. So here we are just converting those. So for example, if we have in the binary class, we have the value in the form of 0 or 1. So we are just converting those integer values into the binary class values. So now here we are just applying the data augmentation. So using data augmentation, we will generate multiple images from a single image. Like we can generate from a single image. For example, if we have hundreds of images from each of the images in the data set, we will generate multiple images using data augmentation. So to implement data augmentation, I'm using image data generator. So in the first step, we are generating from a new image from a single image using by rotating that image using the 25-degree positive direction. Then we are generating applying width shift range as well. Then we are also applying height shift range as well. Then we are also doing shear range, zoom range, applying the horizontal flip as well. And then we are doing the fill mode as well. So using data augmentation, we apply multiple processing into the images and generate multiple images from a single image. So now here I'm just initializing my VG16 model, and here I've just passed the input dimension of the images 100, 100, 3, and we are using the ImageNet weights, and we are not using the top layer. We are on defining our own top layer, and plus we are not training the VGG model again. We are using we are just fine tuning. So basically fine tuning is we are just using the pre-trained model and training the pre-trained model on our data set, which is of gender classification data set, which contain images of men and women. So we are just doing the fine tuning. We are just retraining the already VG16 model onto our gender classification data set images. So we are not doing the retraining the model. We are just fine tuning the VG16 model, and then we are just implementing flatten. So I think I've just missed this cell, so that's why that's already disappearing. So then we are doing the flattening. So we are converting multiple dimension in output into a single dimension using flatten. Okay. So as we have two folders over here, men and women, so the size of the folder will be two, and our output will the size will be using dense layer. We define our output layer. So our output size will be two. Basically, we expect two forms of output. Either it is men or the woman. Basically, when we pass an input image and we want to check the output, so it can be in the form of two outputs. Can be possible from there, men and women. Okay, so here we have the model of summary. So this is the how we have this is how our VGG models look like. Then we will compile our model, and then we will define the batch size. And here we will do the training. So I have already trained the model on 100 epochs. This is a quite time-taking process, so I will not do the training again. Okay, after doing the training, you can save the model in the .h5 format. So I have already saved the model into the .h5 format and downloaded it. And here are the training accuracy, validation accuracy, and loss plots, which you can see over here. And here I've just tested on a sample input image and see what results we have. So I just passed my input image over here, and using CV2.resize, I resize the image into 100 cross 100 dimension, and then just converting the image to array, and then do the expand dimensions here, and then predicted whether as I passed my own image, so it's correcting, predicting that I'm man, so that's fine. So in this way, you can test on any other image as well. So this is all from this video tutorial. Uh, Sorry, this is not all from this video tutorial. So this is all from this part of the video tutorial. Like we have trained the we have fine-tuned the VG16 model on the gender classification dataset images. So now in the next part, we will use this model. Like I have saved the model in the .h5 format. So we will use this model, and we will train our YOLOv8 model on the face images. Okay, so after detecting the faces using YOLOv8, we will use this model to detect the gender. For example, using YOLOv8, we will detect the faces, and after detecting the faces, like where we have the face in the image. So after we detect the face, then we will do pass those bounding boxes coordinates into this gender classification model, like in this model.h5. So using this model, then we will predict whether it is a man or a woman. So and then we will do the count as well, what how many people we have in a specific area. So let's move towards the next part and train our YOLOv8 model on the face images dataset. And then we will do the classification after detecting faces, like whether it is a man or a woman. Okay, then we will also do the count as well. So let's move towards the next part. After training or fine-tuning the VGG16 for gender classification, now we will train the YOLOv8 model for the face detection. To train the YOLOv8 model for the face detection, we will use its dataset of faces, which is available publicly on RoboFlow. The dataset consists of 1,369 images. And as you can see over here, we have only one class, which is face. So as we are detecting only face, so we have only one class, and here we have the data set. So as we have originally we have 1,369 images. So after applying data augmentation help us to increase the size of the data set by applying different pre-processing on the images, like by generating multiple images from a single image, like rotation, shear, zoom. So here we after applying data augmentation on the training dataset images, we have 2,900 images in the training set, 267 images in the validation set, and 145 images in the testing set. So we will be using this images data set to train our YOLOv8 model. Okay. So in the first step here to implement the face detection. So basically in the first step, we need to train the YOLOv8 model for the face detection. So using this data set, which I have shown you over here. So in the next step, after detecting the faces, we will add the classification weights. Like in the previous script, we saved the VGG, after training the VGG16 model on the gender images of men and women, we saved the model weights in the .h5 file. So we will add the model weights into the YOLOv8 code, and after detecting the faces, we will do the gender classification. Plus, we will also do the tracking. We will assign each person a unique ID. So for tracking, we will use DeepSORT. Okay, so let's get started. Plus, in later, we will also do the face counting as well. Okay. So let me implement, right? So face counting, there is a simple code which we use for face counting. It's a 4 to 5 lines code, which we will add in the predict.py file. So to implement this, all this, we will follow these following steps. Here I've divided the complete script into these 7 steps, which are listed over here. In the first step, we will import all the required libraries. Then I will clone the YOLOv8 with DeepSORT object tracking GitHub repo. So to implement the object tracking using DeepSORT, I will use this GitHub repo, which is over here. So I will be using this GitHub repo for this project. So this is I have created this GitHub repo. For I will share this link, or even you can simply type YOLOv8 DeepSORT object tracking on Google. This link will appear in front of you. So we will be using this GitHub repo for this project, and then we will train the YOLOv8 model for the face detection. So after detecting the faces, we will add the gender classification code in the predict.py file. So after detecting the faces, we will do the gender classification, like whether it is a man or woman. Then we will integrate the deep sort object tracking code so that we will assign each of the person a unique ID. So basically the aim of the object tracking is to assign each directed object a unique ID. Then we run the script and test on multiple demo videos. So starting from the first, we will first import the required libraries. So I have already run this script. So just let me change. Please make sure. So let me just disconnect and delete the runtime. So let's get started from scratch because I've already run the script. So there were some previous files appearing. So before running the script, please make sure that you have selected the runtime as GPU. Now in the next step, we will first import all the required libraries. So basically we are importing the image library. We use the image library when we want to display any input or output image. Then I will be cloning this GitHub repo into my Google Colab notebook. So just click over here, copy this, and just clone this GitHub repo. So this repo will be downloaded and it will appear into my Google Colab notebook. Okay, so now we can see this GitHub repo over here. Okay, so now basically now I want to set my current directory as this GitHub repo. So just click over here, click on copy path and just paste this over here. So in this way, you can set this as the clone repo as your current directory. So now in the next step, we need to install all the required libraries or the dependencies that are required to run this script, like training, validation, prediction. So if you run this pip install -c.dev, it will install all the required libraries. So you will not face this issue later in the script that following library, Hydra library is not installed, Matplotlib library is not installed, or Seaborn library is not installed. So it's always better to install the required libraries, or you can say the dependencies that are required to run the script successfully. So now I'm just installing all those required libraries or the dependencies that are needed to run this script successfully. So this might take some time. So please bear with me. As this completed, then we will move ahead shortly. Okay, so you can see that multiple libraries are being installed and some are already by default installed in Google Colab, so it's appearing requirements already satisfied, while some of them are not installed, so they are getting installed. So now as we are implementing face detection, so we need to go to the detection folder, which is over here, and we will set this as our current directory because it contains the training, prediction, and validation script. So let's set this folder as our current directory. Okay, so now I will just download this dataset from RoboFlow into my Google Colab notebook. So just click over here, download. And if you haven't signed in, if you haven't created your account, so it's better to create an account over here. So I'm just signing over here. So just give me a minute. I think you cannot see the screen, but it's okay. So I just have signed in. Now you can see my name over here. So now I will select the format as YOLOv5. Basically, YOLOv8 and YOLOv5 both were released by Ultralytics. So you can select any of the format. And I click select accept the terms and arguments and then select the YOLOv5 PyTorch. Click on continue. So the download code will appear. So just copy this from here and add this into over here. So in this way, if you run this cell, the dataset will be downloaded from RoboFlow into your Google Colab notebook. So here I'm just downloading the dataset from the RoboFlow into my Google Colab notebook. Okay, I think I missed one thing. Okay, API key is not appearing, so just copy this. Okay, I think I have not created account over here. So this was my other account API key. So I'm just using this API key. So I think I have not created a public account over here. It must be a private account. So that's why I'm not able to export the dataset from RoboFlow into the Google Colab notebook. But if you have created your public account, you can just follow the same pattern by just going here, just copy this. And in this way, you can just export a dataset from RoboFlow into your Google Colab notebook. So just click on here, click on copy, and so please make sure that you create a account with the public plan. Okay. So if I run this, so in this way, I will be able to export this dataset from RoboFlow into my Google Colab notebook over here. So now you can see the dataset is being downloaded. So the dataset is big, so it might take some time to get completely download. So in the meanwhile, please bear with me. So the dataset gets downloaded, and then we will further move ahead and train our YOLOv8 model for the face detection. So this might take some time. So I'm also waiting, and as the downloads complete, then we will go ahead and further explore things, other things. So it's 89% downloaded, 96, and it's so the dataset is completely downloaded. You can see over here, it's 100% downloaded, and we can see the dataset folder over here, face detection. So the dataset consists of train, test, validation folder, and here we have the data.yml file, which contains the number of classes. We have only one class. We are detecting the face, and here we have the training, test, and validation images path. Okay, so I have already trained the YOLOv8 model for the face detection. So it took around 3 to 4 hours. So I will not do the training again because it will get the video very prolonged. So I have trained the model for 80 epochs and I have saved the weights after training. So um, you can see over here, I have trained the model for 80 epochs. The image size is set as default 640, and here I've just passed the dataset location, okay, which is over here. And here I'm using YOLOv8L model, pre-trained model for, and here I'm just running the train.py script because I'm training or fine-tuning the YOLOv8 model for the face detection. Okay. So here I've run the model for 80 epochs. So you can see over here the mean average precision gets improved, and on the 79th epoch I got a mean average precision with IRU 50 as 0.9004, which is 90.4%, and mean average precision with IRU 50 to 95 is 58.5%. So the results are very good. So I have already saved the weights into my Google Drive, so I will just directly download the weights from the Google Drive into this Google Colab notebook. So I have just placed the weights into my Google Drive and just downloaded those weights from the drive into the Google Colab notebook. So now you can see that I have saved the best.pt weights file. So I'm just downloading the weights from the drive into the Google Colab notebook. And you can see the weights file over here, best.pt. So I've downloaded the weights from the drive into the Google Colab notebook. I've already validated this model on the validation dataset images. So the mean average precision I got on the validation dataset images is 91.2%, and mean average precision with IRU 50 to 95 I got is 58.9%. So as we are implementing or tracking using DeepSORT, so I will download the DeepSORT files from the Google Drive into my Google Colab notebook because we are implementing object tracking using DeepSORT. So what is the aim of the object tracking? Of using object tracking, we assign a unique ID to each of the detected object. So as you know, in the last part of the video, previous part of the video, we trained the VGG16 or fine-tune the VGG16 model for the gender detection, or you can say the classification. So I have saved there. I've trained the VG16 model and saved the model in the .h5 format. I hope you all know. So I have after downloading the model .h5 file from there, after training the gender classification detection model using VGG16 on the gendered images dataset, I have saved the model in the .h5 format, and I have downloaded the model from the Google Colab, and I have pasted the model.h5 file into the Google Drive. So I'm just downloading the model.h5 file from the Google Drive into my Google Colab notebook. So this is my gender detection model h.h5 file. Okay, so if I see over here, here we can see the model.h5 file. Okay, so this is for the gender detection. We have trained the VG16 model for the gender detection, and this I have saved the model weights in the .h5 format. And after downloading the model weights, I have placed the weights into the Google Drive. So I'm just downloading the weights from the Google Drive into my Google Colab notebook. Okay, so now I'm just downloading sample videos from the Google Drive to test my prediction.py script and see what results we got. I will, before running the script, let me explain the predict.py file and show you where I added the gender classifier code and how we will do the face counting as well. Okay. So if we start from the start, so this is all the YOLOv8 code. I will only explain the code which I have added. So here I have just imported the DeepSORT because I want to implement object tracking using DeepSORT. And okay, so here I've just initialized the tracker. So if you go to this repo over here, if you go to this Google Colab file from over here, this Colab file in this Google Colab file already, if you run the predict.py script, already a DeepSORT code is integrated in the deep predict.py code. So if you run this predict.py file in this Google Colab, already the DeepSORT object tracking code is integrated or added in the predict.py script. Okay. So here I'm just initializing the DeepSORT object tracker over here, and here I'm defining a function which convert the output received from the YOLOv8 model into a format that is compatible with DeepSORT. Okay, but we have so we are just converting the output received from the YOLOv8 model into a format that is compatible with DeepSORT object tracking. Okay. So here I've just defined the color for the labels, and here we have the draw dash border function to create a rounded rectangle for the text. Here we have the UI dash box function. So in the UI dash box function, we create a bounding boxes around the detected object like faces over here. And in the draw dash box function, we just call the above two function draw dash border, draw dash UI dash box. So in the draw dash boxes function, we basically draw the rounded rectangle, and basically we call the up to above two functions over here like UI dash box function and draw dash box function in the draw dash boxes function. And here we also integrate the DeepSORT tracking code as well, which you can see over here. And we, if you want to draw the trails, we also draw the trails over here as well. Okay. So, but we don't need the trail, so you can exclude this part of the code as well. Okay, we don't want to draw the trails. Okay, so let me also explain you the code where we had it, the gender classifier over here. I think one thing I am missing over here is okay. So before let me update download the updated predict.py file. Basically, this predict in this predict.py file, gender classifier code was not on it. So if I open this predict.py file, now you can see that the gender classifier code will be added. Okay, so here all the things are same. Like here we are also importing the DeepSORT to implement the object tracking over here. Okay, so here we have the count. So using this count, we count each of the object in each of the frames. So let me open the paint file and try to explain you from start over here. Okay, so let me just open the paint.py file. Okay, so I will come towards this count function in the last. Let me explain the other code in the meanwhile. Okay, so here what we are doing is where basically let's before moving ahead, let me explain the complete code. Here we have created the function xy to xywh. What we are doing is that we are converting the output received from the YOLOv8 model to a format that is compatible with DeepSORT object tracking. So what output received from YOLOv8? Let me explain to this to you. Let me open the paint file over here. Okay, so now you can see the paint file in front of your screen. Let me check why it's not open. Okay, so now you can see the paints file in front of your screen over here. Okay, so basically the output received from the YOLOv8 is in this format. Let me write x1, y1, and this is the x2, y2. So we get these four values in the form of output that we received from the YOLOv8 model. This is the x1, y1 point, and this is the x2, y2 point. Okay, so this is the these are the four values which we received from the YOLOv8 model, x1, y1, and x2, y2. So these are the four values which we received from the YOLOv8 model over here. Like this is the x1, y1, which represent this corner point over here, and this is the x2, y2, which represent this corner point over here. Okay, so we want to convert in the format of, let me, xc, yc, and wh. So XC, we want to convert them in the form of a XC, YC, W, and H. Okay. So what is XC, YC is basically the center coordinate over here. We want to convert these values into the center coordinates of the bounding box. This is the center coordinates of the bounding box, and this is the height of the bounding box. Okay, and this is the width of the bounding box. Okay, so this is the height and this is the width. So what output we received from the YOLOv8 model, which is x1, y1, x2, y2, we convert those values into for each bounding boxes we receive these coordinates, like these are the x1 y1 coordinates and these are the x2 y2 convert. So we want to convert these coordinates into xc yc, like the center coordinates, we want to find the center coordinates and the width and height of the bounding box, like wh. Okay, so in this way, we want to convert our YOLOv8 model into the XC, YC center coordinates of the bounding box and width and height of the bounding box to make it compatible with DeepSORT object tracking. Okay. So if I go back to the code further, next we are using this function. We will not be using this function over here, so you can skip it. So then we have created a function compute color for label. So what we are saying is that if the label is 0, it is for person, then the basically what I'm saying is that in the compute color for labels function, just remember this function name. So for example, we have detected the person and we have a bounding box around it. Okay. So what I'm saying is that if the person is detected in the video, there should be a specific color of like gray should be assigned to the person. And if the car is detected, then there should be a color of black. Okay. And if there is something truck is detected, then the bounding box color should be like blue over here. Okay. And if there we have detected a bus over here, then the bounding box color should be a red. Okay. So basically we are assigning a unique color to each of the detected object if the unique object falls in this list over here. Okay. Okay, so if the object fall in this list over here, we will assign this unique color which we have defined over here to the bounding box and as well the label where we put the text like rectangle above the bounding box where we put the text. Okay, so if the detected object is not from these, like in currently we are detecting face and the face does not lie from among these classes. So in that case, what we will do is basically we will randomly select a color from the color palette and assign that color value to it. Now we have defined a draw dash border function. So using draw dash border function, what we are doing is that using draw dash border function now, which you can see as well. Let me just remove this all. Okay. So now you can see as well, when we detect object, we have a above on the above, we also have this kind of rectangle. Okay. So using like you can see that this rectangle on which we basically put the value like where we put the label like this is a face, this is a person, and we have the confidence value over here. Okay. So this is the detector bounding box around the detected face, for example, and here we have the label face, and here we have the confidence value. So using draw dash border function, we basically create this rectangle above the bounding box. We'll put the label like if the we detected the face, we'll put the face. If we detected the person, we put the person and the confidence. So using draw dash boundary function, we create the above rectangle where we put that label and the confidence score. Then we have the UI dash box function. In using UI dash box function, we create a rectangle around the bounding box. So let me show you. In the UI dash box function, we create this rectangle using UI dash box function. We create this rectangle. Okay. We create this rectangle like the rectangle which we create around the detected object, which we say bounding box. So using UI dash box function, we create a bounding box around the detected object. Then we have the draw dash boxes function. In the draw dash boxes function, we basically call the draw dash border function and the UI dash box function to create the rectangle or the bounding box around the detected object and assign the label as well. And then in the draw dash boxes function as well, we are calling the gender classifier as well. So let me explain you where we have the gender classifier over here. If we see over here, we have created a class by the name gender classifier over here. So in this way, what basically in a video frame, we get in the video, we get the we process each of the frame one by one. Okay, so we divide the complete video into, if you, for example, if you have a 30-second video, we can divide the complete video into 623 frames, and we do the processing on each of the frame one by one. Okay, so once we have here, we are just loading the gender classification model weights like model.h5 file over here. Then, for example, if we receive the current frame, then we resize the frame of the current frame received into the size 100 cross 100, and then we basically convert the image to array like we discussed previously, and then we expand the dimensions over here, and then basically I'm just loading the gender classification model over here, and then I'm doing the prediction over here. Like if the value is 0, then we can say that the man is over here, and if the output prediction value is 1, then we can say that woman face is detected. Okay, so we are just creating this class for the gender classifier over here, and then I'm just calling this class over here. So after so let me show you. So after we detect the face, like this is a person over here. For example, this is a person we have. Okay, so this is a person which we have detected. Okay, so after we detect the face of this person over here, for example, we have detected the face. Okay, so now we will only pass this face, like these face coordinates, like we will only pass this face coordinates to the gender classification model. So we will only pass this bounding box coordinates. Okay, so we will, okay, sorry, I'm now just redirected towards the paint. Let me just redirect towards the paint. So now you can see over here, for example, we have this person over here, and we have detected uh, the face. Like you can see over here, we have detected the face, and I have created, for example, in a video, we have detected the face of the person. Like you can see over here, I have created this bounding box. Okay, so so now you can see that I have detected the face of the person, and I have just created a bounding box around the face over here. Okay, so once we have detected a person and we have created a bounding box around the face of the person, so now to do the gender classification, like whether it is a man or woman, so we will not only pass the face coordinates. Let me just explain you as well. So I will only pass this face coordinates value like x1, y1, and x2, y2. So I will only pass these four values to the gender classification model to do the prediction like whether this is a man or woman. So after detecting the face in a video frame or in an image, I will pass these four values of the bounding boxes, which we draw around the face, to the gender classification model to do the prediction like whether this is a man face or a woman face. Okay, so let me go back to the code. So now you can see that after we detect the face, we only pass the bounding box coordinate values like which we draw around the face. So I only pass the bounding box coordinate values over here over the gender classification model to do the prediction like whether this is a man face or woman face. And after we get the prediction like this is a man face, we just add the label above the bounding box that the man face is detected. If the woman face is detected, we just write in the text that woman face is detected. So here I have added the gender label dot dash label like whether it is a man face or a woman face. Okay. Now in the next step, what we do is basically now to do the count as well. Like so, let me explain the code for the count. I think where I have added. So here I have after detecting the the faces and doing the gender classification like whether this is a man or woman. So now over here I will just call the function count to do the count like uh, how many faces were detected in the current frame. So I have created this function count over here. So let me explain this to you as well. So I have just created this function count. So what does it basically do is in the foundry dash classes, I have created a dictionary by the name foundry dash classes, which I have initialized over here. So if you see go over here, so you can see that I have created a dictionary by the name foundry dash classes. Okay, so in the dictionary basically foundry dash classes is the dictionary which contains two values. One is the key value and other is the one is the key variable and other is the value variable. So okay, so in the key variable, like this is the key variable in the dictionary. So in the key variable, we will store the count like face, and in the value variable, we will store how many faces were detected. So the key variable will be face, and v value will be how many faces were detected in the current frame. Okay. So I will just store all the detected faces in the current, all the detected faces values. So for example, in the front frame, we detect 5 faces. So all those values will be stored in the founded dash classes dictionary, and it will be shown in the U above in the top of the UI, like in the current face frame, 5 faces were detected. If 10 faces were detected, then it will be written that in the current frame, 10 faces were detected. Okay. So in this way, we do the count like in the current frame, how many faces were detected. And in the founded dash classes dictionary, I stored the count like either in this current frame, 5 faces were detected or 10 faces were detected. So the count, how many faces were detected in the current frame, is stored in the founded dash class dictionary. In the founded dash class dictionary, the first uh, in the founded dash class, basically a dictionary consists of two values. One is the key and other is value. Key variable and other is the value variable. In the key variable, we have the face, and in the value variable, we have the how many faces were detected in the current frame. So here we are just doing the count, like how many faces were detected in each of the frame. Okay. Okay, and using DeepSORT of dot update, I'm just assigning a unique ID to each of the detected face. Okay, so now you can see that we have used the count function over here, and in the count function, we are just showing how many faces were detected in the current frame. So, okay, okay, so that's all. So you can see that here I'm just doing the count of objects. So, and here I'm just doing the foundry dash classes dictionary. I'm just storing the model dot name is that face is the model dot name, and int n is the count, like how many count faces were detected in the current frame. Okay. So this is all, and here I'm just doing the detection per class, some of the detections per class over here. Okay, and this is all from the code point of view. And here I've just told you that we have created the gender class and danger classifier class over here. And so this is all from this code explanation from here. Let me run the code and show you what results to get. So here I've just passed the face detection model best weights over here. So here I have just passed the face detection model best weights, and here I've just passed the demo video on which I want to test my I want to run the predict.py script. Okay. So I have already done this on this script on this demo video. Basically, this takes a lot of time because we are just passing two models. One is a gender classification model and other is the face detection model. So the script takes quite some time to run even on GPU, but I have already done this script. So let me show you what results do we get. So I've tested this model on multiple demo videos. So let me just download this video and show you what results we are getting over here. So if I just navigate my screen over this video, so now you can see over here, okay, so like you can see that woman face is detected over here, and woman face is also detected over here. Okay, and this here we also detect the woman face. Okay, and here we have the man face over here. So the model detections are working quite fine. Okay, so we can say that the model detections are fine. Similarly, in this way, you can test on other videos as well. So let me just download this video and show you what results we are getting. Actually, okay, so just let me navigate my screen towards this video. Okay. So now you can see over here, we are detecting the men, and where we have the woman, we are also detecting that there is a woman. Okay, so when where we have the man, we are detecting the man, and here you can see that we have the face count in the current frame, like how many faces were detected in the current frame, and this value changes as each with each of the frame. Like in this frame, we have three, we have one, we have four, we have two, and we have now eight as well. So let's test on some other video as well. Okay, so I've just tested on this video as well. So let me just download it and show you what results we get over here as well. So let me just play this video. Okay, so now you can see over here, if I just play this video, okay, so now you can see that we are detecting the men and women faces over here, and here we have the count. Like you can see, the count is very rapidly changes in with each of the frame, like in current some frames like 10, 12, 13, 15. So these are the number of faces which are detected in each of the frame. Like in the last frame, 17 faces were detected. So this is all from this video tutorial. So I hope you have learned something from this video tutorial. See you all in the next video tutorial. Till then, bye bye.